Hello students, let us continue. In the previous class we completed till LCM. Now let us start HCF. HCF means highest common factor. It is also called as greatest common divisor or greatest common measure. Okay. So suppose there is two numbers A and B. Suppose there is two numbers A and B. Okay, A and B, and there is one number which is supposed D, and D divides both, like D divides A and D divides both, B as well. D divides A and D divides B also. Then that means D is a factor of A and B. The biggest number which is factor of A and B is called as highest common factor. Correct? Okay then. So how do you write? Suppose D is the biggest number which divides A and B. Okay, so how do we write? Write it like this: HCF of A and B is D. Okay, this is the way you write. Okay, and when it comes to a factor, it is always a positive number. Okay, one of these number can be negative, like one of A and B can be negative, still D is going to be a positive number always. So the HCF is always a unique positive integer. Okay, so HCF of two numbers is a unique positive integer always. Okay, so suppose if HCF of A and B is equal to D, which I have given here, right, which I have written here. Okay, then that means HCF of minus A and B is also D. Okay, HCF of minus A and minus B is also D, and HCF of A and minus B is also D. So D, the divisor, the common factor, okay, or the divisor is always a positive integer. Okay, so let us solve few problems using prime factorization method. Find the HCF of 24, 28 and 40. Let us solve. Okay, so 24, what are the prime factors of 24? 2 12s are, then 2 6s are, 2 3s are, 3 1s are. When it comes to 28, 2 14s are, 2 7s are, 7 1s are. For 40, 2 20s are, 2 10s are, 2 5s are, 5 1s are. Right? So for 24, I can write it like this: 2 into 2 into 2 into 3. For 28, I can write 2 into 2 into 7. And for 40, the prime factors are 2 into 2 into 2 into 5. What is common in all the three? 2 2 2 is common, and then again 2 2 2 is common. That's it, right? So my HCF is going to be 2 into 2, which is 4. Correct? So my HCF of 24, 28 and 40 is 4. Okay. The other way of writing can be 2. Now 2 into 2 into 2 can be written as 2 cube, okay, into 3 raised to 1, okay, and here I can write as 2 square into 7, and here I can write as 2 cube into 5, right? The common factor here is only 2, right? 2 is common, and then 3, 7, 5, they are not common. Okay, which is the least power? Like this is 3, this is 2, this is 3, so 2 is the least power, right? So this is my HCF. So HCF is 2 square. 2 square is 4. Okay. I'm sure you all already knew how to compute HCF. Okay. So this we computed using prime factorization method. So HCF of 24, 28 and 40 is 4. Let's solve the next problem. Find the HCF of 72, 114 and 198. Okay, we are solving using prime factorization method. So 72, 2 36s are, 2 18s are, 2 9s are, 3 3s are, 3 1s are. Prime factors of 114, 2 57s are, 3 1s are 3, 27 9s are, okay, so 19 1s are, okay. 198, 2 9s are 18, 9s are 18, and then 3 33s are, and then 3 11s are, 11 1s are. So the factors of 72 are, the prime factors are 2 into 2 into 2 into 3 into 3, okay, which can be written as 2 cube into 3 square. And for 114, I can write 2 into 3 into 19. Okay. And then for 198, I can write 2 into 3 square into 11, right? So the common factors here are 2 and 3, okay. The lowest power is 1, correct? So here also and here as well, the lowest power is 1, okay. So my HCF of 72, 114 and 198 is 2 raised to 1 and 3 raised to 1, which is 6. Okay, let's solve the next question. We will use division method and solve. Okay, find HCF of 63 and 35. So in division method, the two numbers are given, 63 and 35, which is the smaller number. 35 is the smaller number, right? So 63 is greater than 35, correct? So in division method, what you do, let 63 be dividend and 35 be divisor. So just divide 63 divided by 35. Okay, when you divide, it will come 1 point something, correct? Use a calculator and do 63 divided by 35. You will get 1 point something. So let's do 65 ones are, 35 ones are 35. Okay, so what is the remainder? 63 minus 35. 8, 5, 28. Okay, now whatever was the divisor, previous divisor, now that will become your dividend. So 35 is the dividend now, and 28, the remainder, is your divisor. Okay, so 28 ones are 28, and what is the, how much will be the remainder? 29, 30. Okay, 7 is the remainder, right? Now 7 is your divisor and 28 is your dividend, the previous divisor. So 28. So here 7 4s are 28. Till the remainder comes 0, you have to keep on doing this. And the last divisor is your HCF. Okay. So the HCF of 63 and 35 is 7. Okay, the last divisor or your last non-zero remainder is your HCF, and this is how you solve using division method. Okay, so HCF of 63 and 35 is 7. I hope you all understood. Let's solve one more problem. Find the HCF of 195 and 495. Okay, so here 495 is greater than 195. So 495 is your divisor. Sorry, 495 is your dividend and 195 is your divisor. Okay, so 495 and 195. Okay, so just let's divide 495 divided by 195. Where's my calculator? $495 divided by 195. It comes to 2 point something, right? So that means, okay, let's do. That means 195 2s are something. Okay, let's do that. 195 into 2, 390. Okay, so 195 2s are 390. So how much is my remainder? 495 minus 390. It comes to 105. Okay, now 105 is my remainder. That will become my divisor, and my previous divisor will become my dividend. So my next divisor is the remainder, so 105, and next previous divisor is my dividend. Okay, so 105 ones are 105. When you divide, it will come 1 point something. Okay, so 105 ones are 105. Now how much is my remainder? It comes to 90. Correct. My previous divisor is my dividend, next dividend, so which is 105. Okay, so 90 ones are 90. Now it comes 15. My previous divisor is 90, so my next dividend will be 90. Okay, now 15 6 are 90. Correct. Now my remainder is 0. So my HCF is the last divisor. So this is my HCF. Okay, this is how you solve this. So HCF of 495 and 195 is 15. Got it? Okay, let's solve one more problem. Okay, when there are 3 divisors, okay, first take any 2 numbers. I'll take these 2 numbers. Okay, so 108 is greater than 72. So let us find divisor, let us find HCF of 108 and 72. Okay, so 108 dividend, 72 divisor. So 72 ones are 72. The remainder comes to 108 minus 72, 36. 36. Okay, and now my 36 will be the divisor and 72 will be my dividend. 36 twos are 72. My remainder has become 0. So HCF between 108 and 72 is 36. Correct? Now this is the HCF between 72 and 108. Now I'll take this 36 and the third number. Okay, so 36 and the third number, which is 234, and I'll calculate HCF between these 2 numbers. Okay, so 2, 3, 4, 36. Can you divide this? Let's see. 234. 234 divided by 36. It comes to 6.5. Okay, so 6. So 36 into 6. So 36 into 6 is 216. So 36 into 6 is 216. Okay, so it must be 18 only, the difference. The difference comes 18. Now the previous divisor will become my dividend, which is 36. Okay, so 18 twos are, just a second, 18 2s are 36. Now this has become 0. Now HCF between 234 and 36 is 18. So HCF between all the three numbers is also 18. Got it? So here I got HCF between 108 and 72 is 36, and here I got HCF between 36 and 234 is 18. So HCF between all the three numbers, which is 72, 108 and 234. 72, 108 and 234 is 18. Okay. So when it comes to HCF, there are few notes. Okay. The note is, suppose there are two numbers A and B, and A divides B or B divides A. Then HCF is equal to the number which divides the other number. Okay. So I'll write it like this. If A by B, that means B divides A, okay, then B, if A divides B, okay, instead of writing like this, I'll write like this, okay, if A divides B. If A divides B, then HCF of A and B is equal to A. A divides B means if you can divide A by B, okay, then HCF will be A. If A divides the number B, okay, and you are supposed to find the HCF of A and B, then HCF is A. Got it? Suppose the two numbers are 4 and 8. Now when you do 8 divided by 4, it divides, right? 8 divided by 4 is 2. So HCF of 4 and 8 is going to be 4. Okay. Now second, if A divides B, that means when you do B divided by A, okay, it is divisible, and A divides C. So with this I mean if you divide if A divides C means if C is also divisible by A, okay, then HCF of A, B and C is equal to A. So with this I mean if there are three numbers, suppose 4, 8 and 16. Okay. Now this is A, this is B and this is C. Okay. So A is divisible by, 8 is divisible by 4. When you do 8 divided by 4, it is 2. Correct? Even 16 is divisible by 4. When you do 16 divided by 4, it is 4. So that means HCF will be 4. So A is the smaller number, B is the bigger number and C is the biggest number. Okay. Third note, if A and B are co-primes, then HCF of A and B is equal to 1. So if they are co-primes, means both are not divisible by each other at all. Okay, or any number. Both are not divisible by any number. I mean, there's no common factor between them. In that case, there's no common factor at all. So HCF is equal to 1. When there are no common factors, okay, then HCF is equal to 1. Suppose my A is 5 and my B is 3. So HCF of 5 and 3, there is nothing, right? There's nothing common. So that's why it would be 1. Similarly, HCF of 9 and 10 is also 1, because 9 is 3 into 3, 10 is 5 into 2, nothing is common. Correct? So HCF will be 1. This is the third note. My fourth note is, if HCF of A, B, C is equal to D, then HCF of B minus A is equal to HCF of C minus B is equal to HCF of A minus C is equal to D. Okay, this we need to prove. Okay, so let's try to prove this. Let's take any 3 numbers. For example, let's take 10, 15 and 20. Okay, so HCF of 10, 15 and 20, it is actually 5, right? Because it's factors of 10 is 5 into 2, factors of 15 is 5 into 3, and 20 is 5 into, okay, no, I don't want to take this, because then it becomes 10 is the factor. No, I'll take some other number. 5 into 5, yeah, I'll take 25. Okay, 10, 15 and 25. Okay, so factor of 25 is 5 into 5. So common here is 5, only 5 is common, so D will be 5. Correct? So the smaller number is A, the bigger number is B, and the smaller and the biggest number is C, and this is my D. Correct? So I have to prove that HCF B minus A okay So what is B minus A? B is 15. Okay, so B minus A is equal to C minus B is equal to A minus C is equal to D. That I have to find, right? Okay, so B minus A. Okay, so B minus A means 15 minus 10. 15 minus 10 is 5. C minus B. C minus B is 25 minus 15. 25 minus 15 is 10. Okay, and HCF C minus A minus C. A minus C is 10 minus 25, which is again 5. So this I can write HCF B minus A. B minus A is 15 minus 10, which is 5. Okay, HCF C minus B means 25 minus 10. 25 minus 10 is 10. No, 25 minus 10 is 15. 20 C minus B. Sorry. 25 minus 15 is 10. C minus B, right? C minus B. 25 minus is 10. And A minus C. A minus C means 10 minus 25. So 10 minus 25 is minus 15. So these are the three numbers. If I do the HCF of these numbers, 5, 10 and 15, it is going to be the same. So 5 is 5 into 1, 10 is 5 into 2, and this is 5 into minus 3. Okay, doesn't matter. Okay, or I can write like this, 5 into 3 into minus 1. Okay, so the common factor is again 5. So 5 is the HCF. So if HCF of A, B, C is D, then HCF of B minus A, C minus B and A minus C is also D. Okay, instead of writing like this, it is better to write, instead of writing like this, it's better to write like this. HCF of B minus A, C minus B and A minus C is equal to D. So it is A minus B, B minus C. No, sorry. I must write like this. B minus A, C minus B and A minus C. Okay. So this is the third note. If HCF of A, B, C is D, then HCF of B minus A, C minus B and A minus C is also D. Okay, and this note we are going to use, or any note we might use in other sums. Okay. The fifth note if HCF of A and B is equal to D, then A is equal to ND and B is equal to MD, where M and N are integers. M and N are integers. Yeah, because D is a factor of A and B both, so obviously it would be, this is not something we don't know, right? What I mean by this is, suppose we are finding HCF of 10 and 15, okay? So suppose HCF of 10 and 15. So what is 10? 10 is 2 into 5 and 15 is 3 into 5. Correct? So HCF of 10 and 15 is 5 because 5 is common. So 10 is A, 15 is B and 5 is D. Okay? So here 2 is N and 3 is M. So A is equal to ND because 5 is D, 2 is N and B is equal to MD because 3 here is M and 5 is D. This is what is said here. If HCF of A and B is equal to D, then A is equal to ND and B is equal to MD, where M and N are integers. Okay, so these are the 5 notes. Okay, let us go through the note again. Okay, yeah, if A divides B, then HCF of AB is equal to A. So I gave you the example. If you are supposed to find HCF of 4 and 8, where 4 is A and B is 8, the HCF is going to be 4, because when you divide, 8 divided by 4 is 2, so 8 is divisible by 4, right? So HCF will be 4. If A divides B and A divides C, then HCF of ABC is A, right? And this is the example I gave. So 8 divided by 4 is 2, 16 divided by 4 is 4, right? So even 8 is divisible, 8 and 16 both are divisible by by 4, so HCF will be 4. Next point, if A and B are co-primes, that means there is nothing common, then HCF is equal to 1. So if A and B are co-primes, then HCF of A and B will be 1. If HCF of A, B, C is equal to D, then HCF of B minus A, C minus B and A minus C is also D, and I have proved using the example, right? HCF of 10, 15 and 25 is 5, and when you do B minus A, C minus B and A minus C, you get the same answer. So that means it's true. The next note, the last one, if HCF of A and B is equal to D, then A is equal to ND and B is equal to MD. Okay, there's nothing to be surprised about. Okay, it's obviously that only, because D is a factor of A and B. So D multiplied by something will be A and D multiplied by other number will be B. Okay, so that's it for the day, students. Have a great day. Thank you very much. We'll come up with word problems in the next class.